3.4, solving a linear system of equations. Essential question, can I solve for both variables in a linear system of equations? First method is a graphing method. In this example, we go ahead and we graph both lines. Where the two lines meet, right here, is what we call the solution. Our second method is called solving by substitution. In this case, we're going to take this y and we're going to replace it with this. And that's what's happening right here. Solve for x. Once we get x, we're going to substitute it into one of the equations, and then we get our y. And here's our solution. This would be the point at which the two lines intersect in our graphing method. Our last method is called solving a system by elimination. When we have two equations right here and we line up the x's and the y's and the constants, what we can do is we can notice that these coefficients of the y terms are opposites. And when that happens, we can go ahead and add them. And adding them means that the y is going to be eliminated, and now we have an equation of only x's. Once we get this x, we go ahead and substitute it like we did in the previous example, and we get our y. So here are the three options. One is graphing, one is substitution, and the other is elimination. And sometimes you have to work a little harder with the elimination. Remember that these systems represent these three possibilities. One, the two lines could meet and you could get an answer. One, when you solve, you may not get anything, and that means the lines are parallel. And the other is that the lines are the same, so you get an infinite number of solutions. Let's go ahead and take a look at this problem. Now, I notice that I have y's, so I'm going to use the substitution method, and I am going to put this right into here. So this is going to be 2x plus 1 equals 2x minus 5. I'm going to subtract 2x on both sides, and then I'm going to get something that's not true. And what's happening is that these two lines are parallel, and that's why I'm not getting a solution. So one of them is intersecting at 1 and has a slope of 2. The other one is intersecting at -5 and has a slope of 2. So when I see something like this, I know I have no solution. Let's try another problem. This one looks like it might be good for the elimination method. So I'm going to take this top one and I'm going to multiply it by -2. So I'm going to multiply this side by -2 and this side by -2. So this will be 4x plus 2y is equal to -6. And no, I need a -2y here. So negative times negative is positive, negative times positive is negative, negative times positive is that. Now I'm going to write the second equation right underneath it. And I am going to get 0 plus 0 equals 0, which is true. And what's happening here is these are the same line. When you get this 0 equal to 0, what we have is two lines that are exactly the same. Okay, I'd like you to try solving the system. Stop the screencast and see what you can do. And here's the answer. The first one I used elimination method because the x's and the y's are already aligned, and I got 0 equal to 0, which means they are dependent or infinite solutions. On this one, I went ahead and used the substitution method, and I got something that didn't make sense, -6 equal to 4. And that's because the two lines were parallel to each other. Okay, try these. Stop the screencast and see what you can do. And I again tried the elimination method, and I ended up getting y is equal to 1, x is equal to 2. So these two lines did intersect. Now when I try the substitution method here, I found I had an incorrect statement, 2 equal to 10, so that reminded me that I probably had parallel lines. Now here's an application. We have the perimeter of the trapezoidal piece of land is 48. So what I can do is I can say I'm going to add up all my x's here. So I know that this 6x plus, and then I'm going to add these like terms here, 12y is equal to 48. Now the rectangular piece, its perimeter 144. So I'm going to add the x's together, and that's going to be 18x, and I'm going to add the y's together, and that'll be plus 36 equals 144. All right, now I think I'd like to multiply this side by -3 and multiply this side by -3 so that I can use the elimination method. So this is going to be -18x minus 36y, and I think I'm missing the y here, equals, and then this will be negative, and 48 times 3 is 4, carry it to 144, and then this underneath will be 18x plus 36y is equal to 144. When I add, I get 0 equal to 0, which means there's an infinite number of solutions. Lots of answers will work. So I can go ahead and say I'll let x equal to 1. And when x is equal to 1, I will get 6 plus 12y is equal to 48. 12y will be equal to 42. So y will be equal to 42 divided by 12, which is 3.5. So that's one answer, 1 and 3.5. And then I could try another, x is equal to 2, and substitute all those values, and I'll get some other answers. Okay, your turn. I'd like you to solve for x and y. Stop the screencast and see what you can do. In this problem, I noticed that two of the angles were consecutive interior angles. They added up to 180, and the others were corresponding angles. And I went ahead and used the elimination method and found x was equal to 18 and y is equal to 18.